What's up, folks? I want to cover an article that I should have covered back in 2023, but this one slipped through the cracks while I was working on other things. So here's the article as it looked back in 2023. So I'm about to revisit this and talk about it. So this article appeared in Tech Radar, and it was written in October 28, 2023. Inspired by the human brain. How IBM's latest AI chip could be 25 times more efficient than GPUs by being more integrated. But neither Nvidia or AMD have to worry just yet. And this article basically lays out what was at this time a research project by IBM to really be a proof of concept, because you notice this thing says IBM research right there on the chip. And this is more of a proof of concept. And you notice IBM isn't showing you what this chip looked like, but they just want to show you that we are working, or IBM is working on finding a way around, or a better way of processing data, and especially data for large language models, LLMs. And if you notice back around the end of 2023, a lot of attention was put on AI systems, AI modeling. ChatGPT was really becoming the system. Everybody was like jumping on the AI bandwagon, and IBM was also joining that crowd. But as computer processor technology evolved, we have to look at this bullshit here. We have to look at where we came from. So normally we had these complex instruction sets, or CISC, that later gave rise to RISC, which is reduced instruction set computers. And I don't know if you ever remember back in around 1993, 92, when PowerPC came out, and it was much faster than what Intel was producing. So Intel always knew that their days were numbered, because they were getting stumped by Motorola, IBM consortium that produced the PowerPC chip back in the 90s. So now it's like this whole thing is happening again with the M1 chip. And this is basically, after reading this North Pole processor is almost a way of getting around the von Neumann bottleneck, which just says the computer CPU processes data a lot faster than they could pull the data from RAM. So they're trying to speed this process up by putting memory, which is right here, by putting the memory on the chip. It's actually here. Let's see, where is that? I saw that in here. So wherever it's at. So basically, the way von Neumann architecture work is, we have this on our current processors. So if you have an old Intel chip, you would have this cache that actually pulls data from RAM. But now we are actually putting large amounts of RAM directly on the chips, because the memory access always been the problem with computers. But also, since we don't have these long distances to run, we also making it so the chip could be more efficient and use less power. And that's one of the key points of this article. So the North Pole processor, they only put a small amount of memory on this proof of concept, and it's only designed to work with a small amount, a small set of data. So it's pre-programmed. So this thing does not have the capabilities to reproduce or produce its own learning modules. So that's exactly what they're saying. So this thing only has 224 megabytes of RAM, where modern computers have upwards to 16 to 24. You could buy a Mac with with that's using similar technology. You could buy one of those with up to 1624 gigs of onboard memory. So they are just trying to say that this is more efficient than using GPUs and our best CPUs. And at that time, the best CPUs were probably the, let's see, yep. So it was these Intel Core, so these 14 Gen Core i7, so i9, and you know, looking at this in 2025, that our Intel is actually being dragged through the dirt, because they are being curb stomped by Apple and AMD. So what Apple is doing is really just killing both AMD and Intel with their new designed chips. So back to this article, they were just thinking more of this concept will really make it so the AI systems will be, they'll be able to make more aggressive AI models. AI systems will have more realistic results, similar to how ChatGPT has produced systems that really can mimic human thinking. And this was the beginning of the technology that's making it so the ChatGPT we use today is so efficient. And why these data centers are popping up all over the place to process this data. And IBM always knew that this is where they need to be. I used to work for IBM back in 2021, and they said that we are going to sell our consumer, or like half of the consultant end of the company, which is currently known as Kyndryl, that they spent off a lot of their consumer businesses to focus more on AI related stuff. It's almost like how IBM got rid of the consumer brand, the computing lines for the consumers, to Lenovo, and that's why you have Lenovo ThinkPads. And IBM is really going back to producing business class systems. So eventually they did release their processor, and it's running on the IBM Z platform. And you thought mainframes were dead. I thought they were dead, but mainframes, well, I didn't think they were dead. I knew mainframes been around, but as we could see by reading this article, that mainframes are not going anywhere. And they decided to name this thing the Telum 2 processor and IBM Spyre accelerator that's going to unlock capabilities of enterprise-scale AI, including large language models and generative AI. And this article appeared in August 2024. So about a year after they finally revealed what the chip looked like, what this chip would look like, and this is that chip. And so they were just saying that this chip is going to be a game changer. And it really doesn't go into a lot, but they did provide this nice video. I always did like IBM. They are my company. So that video sums up what they're trying to do. So, and now AI power demand skyrockets 75% annually. So they are building AI data centers, and they are actually wanting to leverage nuclear fusion technology as it comes aboard, because that is going to be the #1 game changer. That's going to be something that's going to change everything. Because right now, our current nuclear development, or the way we develop power plants for nuclear energy, is through fission that leads to waste that no one knows what to do with the shit after the decommissioning, all the use of the nuclear contaminated uranium, whatever the hell but I think it's plutonium actually. Whatever they do to the radioactive waste after its use, and radioactive water, that's wastewater and all that other stuff. I mean, you just go back and look at what happened in 2011 when 2011. Damn, that's a bad year there. Back in 2011 when they had the earthquake in Japan and the Fukushima plant went what they call it went into a meltdown. That's what they call it. And then you might notice that you got a chance to see how dangerous this stuff is. And 3 Mile Island, that damn near melt the core, reactor core melted, and then the big boy, the most dangerous bastard of all of them, was the Chernobyl accident. You still can't go around that planet. I mean, that's to show you just how dangerous that was. So what we are looking at is some of the applications. So really, this AI will be used mostly for, and these are business applications, insurance, fraud, claims detection. Now, that might be, I do not like insurance companies, so I really would like to see them get played the whole time. Advanced money laundering and AI assistance, we know those. But I also want to address another part of this story that haven't been talked about, and that's IBM commitment to quantum computing. And I really think IBM is going to be the company. So if you want to invest in stocks, if it's feasible, buy some IBM stock, because I really think that by them being the leader in quantum technology will make it so we know that quantum technology will be running these AI models sometime in the future. But right now, what they are doing with this AI, using chips, using the new style of processors in their mainframe systems, that's a game changer. That's really all I wanted to talk about with an update to this article. As this stuff becomes more common, you are going to see a change in the paradigm. Intel is in trouble, and even AMD is in trouble because they are not adapting to this new style of making processors. And we know when I say new style of processor, I'm talking about ARM. ARM been around for a long time, if you're old like me, but the progression of ARM has been exponential compared to how Intel been creeping along these last few decades. And that's why Intel and AMD are in trouble. I mean, they not moving on to what TSMC and all these other companies out of China is doing with, as far as making ARM the relevant processor architecture. And I see that's about it for this video. So till I make my next video, it's the Savage Scientist Ed with a long rambling video. Till next time, peace out.